All right. Um, so this panel is about interoperability and multi-chain future. I think we could start off with a quick round of intros of who you are and what you're doing with your project. And yeah, go ahead. Jay, you want to start first?
Hi, everybody. So, wait, okay, talk really loud. So my name is Chris Winter. I'm replacing Jay, my co-founder. He had to actually catch a flight, but I am the CEO of a company called Reach. What Reach is a blockchain development platform that is blockchain agnostic, but it's exponentially faster, safer, and easier to learn how to build a blockchain application. I like to talk in like real use cases. We can take a traditional Web 2 developer and train them for about 4 to 6 weeks, and they can build things like AMMs, decentralized stablecoins, things of that sort. And you know, it's been pretty fun so far.
Awesome. Hi, everyone. I'm Arjun. I'm one of the founders of Connext. Connext is an interoperability protocol. We allow developers to build fully expressive cross-chain communication apps in partnership with Nomad. We are live and have been for a while. We've actually been in this space for like almost 5 years now. Excited to jump to this panel.
Hey everybody, I'm Anna Carroll. I'm the protocol lead at Nomad. Yes, please hold your applause. Nomad is a protocol for cross-chain interoperability that uses optimistic dynamics. We're live on mainnet right now, deployed between Moonbeam and mainnet Ethereum. And yeah, we're partnered really closely with Connext as well.
I'm Park. I'm from Figment. We're a multi-chain validator. We validate on over 35 different chains. We have a lot of presence across different ecosystems. And we have a lot invested, both financially and also just culturally in terms of the growth of the entire space. So I'm really glad to be here to talk about this because this is something that we care a lot about as an organization.
Great, thank you so much. I'm going to start with a blog post, or not a blog post, a Reddit post that Vitalik has written about multi-chain versus cross-chain. Have you guys read the blog post last month? I think Vitalik is optimistic about multi-chain, where we're in a world where there are multiple chains, but he's less optimistic about cross-chain applications, primarily due to the fact that bridges across sovereign zones are not that secure. Do you agree? Do you disagree? And what do you think? Or, yeah.
I'll go first. So I 100% agree to that. I believe that I believe in a multi-chain world, but at least in the current iteration of things, the inefficiencies of bridges, where at the very best it's bridges assets at the least common denominator, it really limits the innovation to be able to bridge from chain to chain. But I do believe in a multi-chain world where there are better chains for better things. And some things can be cross-chain, but the large majority of things can't be cross-chain.
And does your IDE or toolchain support bridging, or is it just a cross-compile across multiple chains?
So Reach is blockchain agnostic, so it allows you to write your application in the Reach language and launch on any chain that we're connected to. Currently, that's all EVM, Algorand, Conflux, and next will be Cosmos, but with the idea that we bridge to, or we connect to all chains. But we do believe that once we actually have a good foothold over the developers, we provide extra better tools that allow for the minimum assets to bridge cross back and forth.
Got it. Thank you. Arjun, you want to go next, or whoever?
Yeah. So this is a really interesting question, and obviously it has become a lot more interesting because of the wormhole hack, which admittedly was related to contract code and not anything else, but it has really brought bridge security to the forefront of everybody's thinking. I think Vitalik is absolutely right, and I'm glad that he's brought this up, that like the security of having a shared settlement layer and interoperability happening with that same shared settlement layer is always going to be better. That said, I don't know if that's necessarily the conversation we should be having, just because the reality is that people are going to do it anyway. And they'll do it using multi-sig bridges. I mean, there's a reason why things like WBTC exist. There's a reason why USDC exists. There is clear market demand for building these kinds of products. And like, I think it's sometimes easy to say, okay, well, that's not the most optimal architecture. But the reality is that if people are going to do it anyway, the better option is to find safe ways to try to do it. Something that we're really interested in is to find, is basically to build in like cross-chain circuit breakers. Have limitations on the amount of funds that can be transferred between chains, even for cases where you have things like wrapped assets. Using techniques like that to add additional levels of verification to cross-chain interoperability, I think can bring us to the point where the amount of downside risk associated with, like, there is a huge black swan risk associated with a single chain getting 51% attacked, and then those tokens going back and potentially being spoofed to Ethereum and infiltrating Ethereum supply. But the limit of that, the effect of that can be significantly constrained if you design systems well, and if you build in fail-safe fail-safes to stop that from happening.
The other thing I think is kind of interesting about this is that we tend to be constrained by the idea that it should be fully financial, a lot of the cross-chain application capabilities. And in the long tail of this, as the space continues to develop, cross-chain is something that could work in a more modular setting, right? When you're trying to build things with multiple components from app chains, that's where like cross-chain could potentially see itself being a lot more useful. So I think right now we're in this like very nascent stage where we're trying to figure out how it is that we can mitigate the risk between all these between different chains, and how it is that we want to like port things between them. But I think it's really a question of like, what are you bridging? Like, how is it that you're using within the space? And I think that we're going to see a lot of development. It's super early in the story of bridges at this time. So yeah, that's.
I'm going to jump in here real quick. I agree completely there. That's everybody hates when you say this, but when people say we're early, but we are. And okay, better. And so when you say we're early, we will figure out the better structures. We will find out the better infrastructures so that we can do those things in the future.
Anna? No? Okay. So does it bode well for blockchains that are designed to be interoperable, like Cosmos or Polkadot, where cross-chain applications are featured by design, versus like across different zones of sovereignty? What do you think of that?
I'm sorry, could you repeat the question?
Yeah, so Cosmos and Polkadot, they're designed to be interoperable between multiple parachains or zones and stuff like that. Is that a better model than crossing zones of sovereignty, where Vitalik, where the security issue is a problem? Or anyone can.
The gut feeling is yeah. Like when you have some sort of message passing protocol that allows you to create that interoperability and you're staying within that zone, the gut feeling would be yeah, because you don't have to worry about like asset transfer in the same way. Go ahead.
Right. The next question is around what is your security model, and how can your bridge fail? What are the systemic risks that exist in your protocol? I guess.
Yeah. No, well, I'll start. So Nomad is based on optimistic dynamics, similar to optimistic rollups like Optimism or Arbitrum. So basically there's an attestation on the sending chain as to the messages that were enqueued on the sending chain. And then those attestations are relayed to receiving chains. There's a fraud-proof period during which watchers can come and basically block fraudulent messages. In terms of like systemic risk on the protocol, I think like James had an interesting talk earlier today, James Prestwich, who's the CTO of Nomad, talking about how none of the bridge hacks that we've actually seen have been a compromise of the trust model of the bridge, but actually just smart contract bugs. So it's kind of interesting, like we can talk about systemic risks in the security models, but I think at the end of the day, like the design of the bridge should be such that minimizing potential for smart contract bugs.
So I'll jump on there real quick. So we have companies building bridges on top of Reach, And I agree, the smart contract issue is the biggest issue. So one of the things that Reach does is that through the compilation process of your application, it automatically generates formal proofs to mathematically guarantee that the code will do what you expect in all potential realities. So we are helping people attack the smart contract side, which we found that is the biggest issue when it comes to bridges.
So for Connext, we are sort of obsessive about trust minimization. We've been like extremely vocal about that. Most weeks I'll be yelling on Twitter at people to not use multi-sig bridges. By the way, don't use multi-sig bridges. The way that Connext works currently is that it's similar to an atomic swap system. You have a network of liquidity providers who are accepting funds on one chain, and that can also include like call data to execute a contract call on a receiving chain in certain limited cases, and then basically fronting capital on the receiving chain in return. We are working towards a newer model that leverages Nomad further at its core, but this core security model is the same. The idea is like there's two pieces of this interop puzzle. The first is the data layer. How do you actually get arbitrary data across chains without introducing trust? And then the second is liquidity. How do you make sure that you get the right asset when you actually get to the destination chain? Because otherwise you're just going to get some completely random wrapped asset that isn't going to be helpful for whatever your specific use case is.
Great, thank you. So I guess Nomad has been out only a month or so, or very new? I'm so sorry. Yeah, Nomad, I'm sorry. Nomad has been only live for a month, is that right?
Yes, so we deployed in January.
Okay. And bridges are being used for asset transfers mostly these days. Have you seen any applications that are doing cross-chain composability of application? Have you seen any creative use of cross-chain message passing?
Yeah, so we actually, little known fact, deployed with 2 production applications. Everybody knows the token bridge, transferring tokens across chains, but actually built into our core system is a cross-chain governance app that governs our smart contracts across every chain that we're deployed on. And I'm looking at this now as a problem that pretty much every application that's expanding to new chains is facing actively. So I've designed a cross-chain governance application that can allow governance on layer 1 to execute proposals on remote chains. So that's one example. We also have just a myriad of developers building on top of Nomad actually right now. So I know Uma was working on a cross-chain sort of price oracle, which is super interesting. I think other folks have been, Connext is now building on top of Nomad as the message passing layer. I think there's a lot of room for us to still explore this design space, right? Because in smart contract design, if you're sort of executing on an atomic layer 1, that atomicity is really important to protocol design. Everything, we assume that there's not asynchronicity in smart contract design, and a lot of the use cases that we have right now on Ethereum mainnet, for example, kind of rely on that. So I'm really interested to see this application space develop and understand how smart contract and protocol developers are going to actually incorporate asynchronicity in their designs.
There's actually, I'm glad that you brought this up because this is something that we've been thinking about a lot as well. So I recognize that it's 5:45 on Saturday, and everybody's dead. But I am going to get a little bit technical with this. So I hope the 5% of people here who understand it appreciate it. There's my goal has always been try to find ways for developers to safely build applications that go across chains and to define what those developer patterns actually look like, because it is a completely unknown space right now. Everything that you do in Solidity happens within the same block. And so you never really have to worry about some of these really interesting problems like, okay, what happens if my execution runs out of gas? Right now, it just reverts. In a cross-chain paradigm, no one really knows. The transaction's kind of just stuck there until somebody pushes it forward. It's really weird and it's uncomfortable. The other really weird thing is how do you deal with just asynchrony in general? In traditional web development patterns with things like JavaScript, you have asynchronous callbacks. You can go and fetch a resource from somewhere else, and then later, at some point in the future, you can come back and execute your code. Can we build that into Solidity? And as it turns out, yes, we can. That's actually something that we're heading towards now, is leveraging Nomad to allow developers to do that, to build an application that can call a contract on another chain, change the state of that contract on the other chain, and then return the call data back to the origin chain. And not just that, but also autonomously execute a callback on the origin chain. I think this is really going to this is probably like the biggest change to Solidity development patterns since we started using libraries. I think it's dramatically going to alter the developer experience in a really, really interesting way, because all of a sudden you're not just thinking of like, okay, I'm calling a contract and I'm specifying an address which is where that contract is deployed on the same chain. Now you're saying, okay, I'm calling a contract and I'm specifying a much longer identifier that includes chain information. And I can interact with this contract operating on another chain in the exact same way that I interact with the contract on the same chain. I think for a lot of people, that's going to be a very fascinating and mind-boggling experience.
That's really cool.
Yeah.
Have you thought about some of the cool applications that you want to see using this model?
Yeah.
Besides governance.
Yeah, there's a lot of really interesting stuff. I mean, the kind of low-hanging fruit is like anything that's like DAO governance-based, kind of like what you were saying. DAOs having to change constants on other chains, or to go and retrieve data from another chain. So imagine you have a protocol that has like protocol controlled value that has liquidity fragmented across a bunch of chains. You need to update PCV constants, or basically trustlessly read PCV constants from another chain and bring them back to your home chain. That's a really, really interesting example. Other kinds of things are like cross-chain zaps, basically baking in the ability for users to instantly jump into an application from another chain without having to think about, okay, I'm going to have to bridge my funds and then use this other application as app. I think bridge interfaces are like boomer tech that is going to disappear in the next 6 months. Hopefully. I really hope.
Right.
So I'm going to ask questions. I'm curious about this now. So does this work with EVM to EVM, or would this work from like EVM to Solana or Algorand or anything of that sort?
Well, yeah, theoretically it could work in any like cross-chain environment. It doesn't have to be EVM to EVM. I think it's in the EVM to EVM world, something that our contracts, like a design feature of our contracts, has been the fact that they're deployed the same on every chain. So these contracts, every contract encodes both the information of how to send messages and how to receive them. So all of that application logic is sort of living in the same place. And what that means is that it's really easy for a developer to build once and then deploy everywhere within the EVM. I think, and we're actually a model for that, for example, right now, because Nomad right now is planning to aggressively roll out to basically as many EVM compatible chains as we can, and that's very doable because we don't have to re-implement the on-chain component. That being said, Nomad was designed to be buildable basically in other VMs easily. It uses simple cryptography that's available on every chain, and it doesn't, unlike, for example, header verification relays, it doesn't use like esoteric application logic that can't be implemented easily in other languages. So I'm really excited to see this play out actually in other chains. Like I think it does potentially explode the design space for like protocol bugs, like smart contract bugs. So it's going to be a lot of fun seeing what goes on with that.
Well, so there's something interesting that you pointed out here that I think is something that at least we're thinking about a lot at Figment, which is like when you have all these interdependencies that start existing between all of the different zones of sovereignty or however it is that you want to build the applications, that means that you are building things that have a point of failure that could be non-dependent on people that are working on the origin contract or something like that. So what I'm really interested in is like, and I think that's where you see the vulnerabilities at this point, right? That's where you're seeing a lot of these issues is you have interdependencies where you can't account for what's happening on the other side of what you're trying to work on. You have like vulnerabilities and instabilities. And so I think that's going to be one of the biggest hurdles is understanding how to coordinate and govern the relationship of making sure that everything you're using in your stack to execute something is reliable. And that's what I think gives me the biggest point of hesitance when it comes to cross-chain work, is because you are depending on something that's far away from you, right? When you're working within your own ecosystem, it's like an M1 chip on an Apple computer, right? Everything's inclusive. You can run extremely quickly. You have a Solana, or you basically I compare the two in my head as like Solana and M1, right? Like, it's not necessarily the case, but that's going to be, I think, the biggest hurdle. And obviously, we in the space, because we care about coordination, we care about the ability to like build things with multiple different modular components. What y'all are doing is important, but that's the biggest risk I see in my case, is the interdependencies.
Yeah, and that's, I mean, I think that's a really valid point, and it's a really important risk. It's sort of like, it's basically like the problem comes down to figuring out, okay, you have this much more complex dependency tree that's created as a result of having these things exist across a bunch of different chains. How do you find ways to reduce the risk of those dependencies? The good thing is we do actually have, in computer science, we do have good models for how to like, constrain dependencies and how to like think about the risk of added dependencies. And there's no reason why those models can't be used here as well. And I think I touched on this earlier, but like models like limiting the ability, like limiting the the downside risk of any specific interaction. So do you ever need to transfer $300 million across chains in a single transaction? No, probably not, because you could.
Depends what you're looking for, right?
Unless you're hacking Wormhole, you don't need to do that. Yeah.
You're flash loading across different chains. I mean.
And so, yeah, I think you can, probably set rate limits, and I think that's probably an acceptable outcome for most user interactions, because the vast majority of users aren't having to really worry about transfers of those sizes. And if you are an institutional user that is doing, multi-billion-dollar transfers across chains, you're probably okay waiting for some time. That latency trade-off is not as huge of an issue.
Well, so there's also something. So we were supposed to have another person on the panel who unfortunately wasn't able to make it. And I don't mean to downplay you, because I'm really glad you're here. But Superfluid is doing streaming payments. And to me, if you can figure that out in the right sense, that actually could be a risk mitigation layer as well, right? So if you want to transfer $300 million or even just $3 million between chains, if you have a stream, you're only like worried about what's getting transferred at any given moment, right?
Yeah, we're getting dangerously close to the original like interledger thesis, which for any of you who have been in the space for a while was like a model for payments across chains where you like break up transfers into very, very small packets, and that way you only have to think about the risk of one packet at a time. So if something happens, you can basically stop this stream of packets. And for what it's worth, like it's a fantastic model. It constrains risk extremely well.
Cool. I want to spend the last few minutes talking about developer experience, which, I want to address the question to maybe Park, which has deployed a ton of nodes, right, on different blockchains, as well as like Chris, which is helping developers have a good experience deploying to multiple chains and all that stuff. So what is the ideal developer experience for cross-chain applications, and what's the, I know Arjun talked a little bit about that, and what's the mental model people should have when developing cross-chain applications?
I'll start. So we believe that we need to make blockchain development exponentially easier, because right now with Solidity development or Solana development or algorithm development, you're building state machines. And traditional developers don't know how to build state machines, or at least well. You go grab a Web2 developer and say, hey, build me a state machine, there's going to be holes in it every time. So what we've done is we built a programming language that is a higher level of abstraction that allows the developers to develop at the level of the participant. And what we do is we derive the state machine from the actual the actions of what the participants are supposed to have. And not only that, but we automatically formally verify the output. So it allows for the developers to insert assertions directly in their code, and it generates formal proofs to guarantee that that code is correct in all potentialities. Because it wasn't just about making it easier to develop, but it was also about making it safer. And the best part about it is that once you hit compile, it compiles to every single chain that we connect it to. Not EVM, not just EVM, but EVM, Algorand, Conflux, soon to be Cosmos. And they don't have to change their code at all. And you talked about earlier about the the issue about other chains working just completely different than what EVM, that's a real thing. And what we had to do is figure out what the effect of the contract's supposed to do, and then be able to figure out the mappings from what the participants were supposed to do to derive that state machine and how it works on that specific virtual machine. So yeah, that is definitely a problem. But like our challenge was to say, not how do we make blockchain development incrementally better, but how do we make blockchain development 10 times or 100 times better? And I believe we've been successful so far. We're launching a AMM DEX at the end of this month, and the pool code is under 300 lines of code, and which is nuts. Which, by the way, the developer that wrote it never knew what blockchain was before that. So we've done it.
Yeah, so this is definitely something I've thought a lot about because I've been developing applications on top of Nomad, so I've also been thinking about what that experience looks like for other people, and particularly other people who are lower context than someone who built the core protocol as well. So something that I think is the biggest challenge in developer experience right now for building on top of Nomad is, so Nomad is an arbitrary bytes message passing layer. So what gets passed between chains is a chunk of bytes. In order to build an application on top of that, you have to make those bytes be saying and doing something meaningful. And so right now, our applications that are built on top of Nomad, the token bridge and our governance application, there's a lot of bespoke bytes encoding. There's a lot of packing bytes, parsing bytes. And we've gotten feedback from developers like that. There's some developers who will just jump right in there and get down and dirty with it, but there are definitely a lot of developers who are uncomfortable with not having like a higher level language for this. And I think part of the challenge there in the mental models is that we've actually done everything at the protocol layer to be reusable on other VMs, on other chains like Solana, Cosmos, Polkadot, for example. And what that means is there's a little bit more mental gymnastics to write an application, even though right now we're only deployed on EVM chains, and there could be easier, simpler ways of doing things. So for example, for encoding bytes in Ethereum and EVM, we have ABI encoding, which is like a standardized encoding scheme that you can use to both encode and decode bytes data. It's just a bit easier to out of the box create your own bespoke message format using ABI. But that's an EVM native thing. So if you want to take that application suddenly to Solana, you are pretty much shit out of luck. And so another thing, for example, is addresses in Ethereum, like they're shorter than addresses on other chains. So when we create an identifier for a contract on another chain, it includes the domain of the chain as well as an address cast to bytes 32, cast to a different size. So it's like a layer of indirection between just directly coding, which a lot of developers like EVM or smart contract developers are used to at least having language at the level of like Solidity. At the moment, we don't have that for this, and so it's a little bit more low level.
You guys will have any quick comments?
I just want to follow on that. So I think like the thing that's kind of missing here is basically just developer tooling. If you were building Solidity applications in like 2016, 2017, it was like a god awful experience. Like holy shit, it was so bad. Oh my god, it was like an excruciatingly painful thing to do. But now you have these wonderful libraries created by OpenZeppelin and other organizations that are like that abstract away a lot of the complexity and then also make the whole process a lot safer. I think like where we are right now with this is a similar place where like right now users are having to deal with like the lower level call functions, the lower level like building blocks that in reality they shouldn't probably be dealing with unless they're very, very advanced developers. What's missing right now is basically wrapper contracts, libraries that can abstract away the whole idea of like how do you get the correct identifier for a contract on another chain. You just pass in the contract address and the chain that you're going to, and it just spits out the correct identifier. Libraries that wrap, in the same way that you have like OpenZeppelin interfaces that wrap like ERC20, and you instantiate like an ERC20 contract by doing like IERC20 address. You just the same thing, but in a cross-chain wrapper that is like X IERC20, and then you pass in this more generic identifier. Once it gets to that point, and this is the ideal. Like once it gets to that point, developers should just not ever have to think about it. Like it should just be like one tiny change where your mental model goes from address on this chain to address on any chain, but that's it.
Great, I think we're out of time. Thank you so much for spending time.
Thank you.
Thank you, everyone.
Thanks, everyone.